You're listening to the Business for Good podcast, the show where you'll hear inspirational stories about companies making money by solving some of the world's most pressing problems. I'm your host, Paul Shapiro, and I'm glad you've joined us. Welcome, friend, to episode 122 of the Business for Good podcast. Well, we got a lot of response to our last episode with Eve Potvin, whom we declared the most successful plant-based meat entrepreneur of all time. Some of you were shocked that you've never heard of someone so successful in the space, while others offered alternative names for the title of most successful in the sector. It is a worthwhile and, I might add, fun debate to have. But given Eve's two successful consecutive exits in the plant-based meat field, I am sticking with our claim that he indeed holds the title of the most successful plant-based meat entrepreneur of all time. If you disagree, though, feel free to let me know why. You can message me via businessforgoodpodcast.com. Now, speaking of messaging me, I would love to know what you think of the show. Are there episodes you thought were great? Maybe some you found suboptimal? Topics you wish we'd cover more? Let us know, which again, you can do at businessforgoodpodcast.com. The goal of this show is to tell the stories of people seeking to use the power of commerce to solve serious social problems. And if you have ideas for improvement, I am all ears. In fact, given that my ears are particularly large, that statement is true in more than one sense. Anyway, I am looking forward to hearing your thoughts. Now on to this episode. Did you know that nearly 10% of CO2 emissions come from the creation of cement alone? That is more than all of aviation. We rarely think about cement, despite the fact that our society would literally collapse without it. Roads, bridges, buildings, and more all depend on this material that's so ubiquitous, we barely even notice it. In fact, concrete is by far the heaviest part of humanity's footprint on the planet, and today, all of the materials that we have built with it are heavier than the weight of all living beings on the earth combined. In other words, the carbon intensity of cement production is a big deal. In this episode, we talk with Sublime Systems co-founder Leah Ellis about her effort to decarbonize cement production, for which she has already raised $50 million. As you'll hear, rather than heating up limestone to hellish temperatures to make cement, which is the currently dominant method, Sublime harnesses the power of electro-chemistry to convert calcium-bearing rocks into cement at room temperature, thereby slashing emissions dramatically. Already, Sublime has built a $10 million pilot plant demonstrating the viability of its technology, and it plans to make its commercial debut within 2023. Next step, build a full-scale commercial factory that can really start making a dent in the climate crisis that Leah is seeking to make. I now bring you Sublime Systems co-founder Leah Ellis. Leah, welcome to the Business for Good podcast.
Thank you so much, Paul. I'm delighted to be here.
I am delighted to have you, especially because I have to admit my pretty deep ignorance on this topic prior to researching for this episode, because I'm just going to straight up admit I really wasn't sure about what the difference between cement and concrete was. I think a lot of people might not be willing to admit something so basic, but I had a vague idea of it. But why don't you just tell us just briefly, like, what is cement and what is concrete and how are they different?
Well, it's funny you say that, because 5 years ago when I got into doing this work, I also didn't know the difference between cement and concrete. So I had to look it up on Wikipedia myself, and it's not a dumb question at all. And in fact, it's one of those things that I I sometimes slip up and I intermix cement and concrete, but they are distinct. So cement is the glue that holds aggregate and rocks together to make concrete. So when you look at, a sidewalk or a slab of concrete, you'll see these pebbles that are all held together by a matrix of cement and sand. So I like to use the paper mache analogy where, the rocks are the paper and cement is the glue that holds everything in shape.
So how much of what you see, like if you're looking at that sidewalk and you see this conglomerate of all these things that are held together by the cement, how much of that concrete is actually cement?
Concrete is about 10 to 15% cement. So it's a relatively small volume, but you have to bear in mind that even though cement is only 10 to 15% of concrete, it is still the world's biggest industry by mass. So we use more cement than any other material besides water. And when you think of cement plus aggregate to form concrete, I recently heard that there's more concrete in the world the mass of concrete exceeds the mass of all living things on Earth. So both plant and animal matter.
Really?
And I thought that was also quite wild. So, it's something that fades into the background for most people, including my former self. You take cement for granted, but it's actually a really remarkable material with remarkable properties that we're likely encased in cement right now, depending on what building you're in. And it's been around for thousands of years. We need it more and more than ever before as the world's population grows and becomes more urban. And also we need more resilient infrastructure for the storms and hurricanes that we should be anticipating with the coming of climate change. So, it's one of those things where once you see it, you really can't unsee it because it's everywhere. And then once you start to learn more and more about it, as I have, the details of the cement and the concrete and the intricacies of it. And, it really just tells a story wherever you go. So it truly is a fascinating material. And I'm just delighted to be on this podcast. So share my enthusiasm for cement. It's not a sexy material. When people think of clean tech companies, they may think of Tesla or, wind turbines or something a little bit more prominent. But, cement is 8% of global CO2 emissions. So I'd love for people to think about cement and the infrastructure that they see around them as part of the clean tech picture.
Interesting. So let's talk about why that is. But I mean, first, I just want to acknowledge, of course, our society would literally collapse without cement, right? Bridges, roads, homes, like it's just everywhere. I was thinking about how you were using the term we're encased in cement. It is so ubiquitous that you don't really contemplate it. But even more than the ignorance surrounding what cement even is, I think, is how cement is actually made. Because you're talking about this as clean energy, but it sounds like, well, you're mixing up a bunch of rocks with glue. Like, what's the big climate problem with that? So first, how is cement made today, and why is this a concern? Like, why should we consider this a climate crisis problem?
Yeah, so the concern comes from the way it's made. So, 8% of global CO2 emissions, and of course, those emissions aren't from, the use of cement or mixing it with water and letting it set. That's not where the emissions are from. It's from the fabrication of cement. And these cement plants are enormous. So the average cement plant is 1 million tons a year, and they're typically located outside of the cities, off the main highways, just because they're located next to these large limestone quarries where they get the raw material. So the cause of cement CO2 problem is twofold. One is the limestone itself, which is the prime ingredient for cement. So that rock is calcium carbonate. It is 50% by weight CO2. And what happens when you put this in the cement kiln, you first heat it up to 900 degrees Celsius. And that's the temperature at which this rock breaks down and decomposes and releases 50% of its weight as CO2. So that's the first carbon intensive reaction. And then, you also have the fossil fuel emissions from heating the rock. And it's not just to 900 degrees. To really make today's modern cement, you have to go up to 1400 degrees Celsius, which is a truly staggering temperature. It's, around the point that rocks melt and you get this sort of flux, and that helps form these particular crystalline phases that make today's cement. So, yeah, and those kilns are fueled largely by bituminous coal. So you really need coal, and particularly coal that makes a very luminous hot flame to achieve these temperatures. So that's what makes cement very, very difficult to decarbonize. One of the biggest challenges in clean tech is cement, because of the size of the industry, because of the high performance required to make a good product, and also the almost inevitable sources of CO2 from the fossil fuel. So those temperatures are nearly impossible to electrify efficiently. And then also from the limestone itself, which is the primary source of calcium. So that is the challenge. And that's what Sublime is is here to fix.
Cool. We're going to talk about how you are fixing that, Leah, but just to recap. So basically, there's two primary climate problems with cement. The first is that just breaking down the limestone releases a lot of CO2, but then also the energy sources used to heat that limestone up to a point where you can break it down and release that CO2 is obviously producing a lot of climate changing emissions also because it is so hot. So just to be clear, like, could you get to 1400 degrees Celsius using renewable energy, or do you have to use coal for that?
Yeah, so you're right. Both of those emission sources are roughly 50% each of cement's CO2 emissions. So 1 ton of cement results in a ton of CO2 emissions, and it's roughly half from the limestone and from the fuel. And you can get to those high temperatures. It's very difficult to electrify because electric heating is resistive heating, and you get heat. The heat transfer is radiative. And also you need metal heating elements. And of course, you run into temperatures with metals being stable at that high temperature. So really, there's like a material limitation and then also an energy efficiency limitation where, it's just not as effective as blowing combustion gases convectively heating the rocks. So it's understood that, you can get some small boutique electric kiln to achieve those temperatures, but it's not going to be efficient. So you're going to have to increase the embodied energy of cement, and you're going to have problems with corrosion of these metals, and also the metals that are stable at these high temperatures are also extremely expensive, like molybdenum, for example. Or so I don't know. I think people, if it was easy to figure out, I think people would have already figured it out because there's an incredible push to decarbonize. But electric kilns may decarbonize, the first part of the process, but getting to those ultimate temperatures is something that you really need. You really need combustion, and even if you're burning hydrogen, that would decrease your efficiency. So yeah, one of the biggest challenges we face is how to make that cement.
We know what the problem is in terms of cement production, and it's not easy to figure out how to do it with renewable energy. So what is Sublime actually doing that's better than heating up limestone to turn it into cement? Like, what's the actual technology that you've advanced?
Yeah, so we have come up with a way of avoiding fossil fuel, avoiding the need for heat and kilns and combustion. And also, by chance, that technology also allows us to use other sources of calcium other than limestone. So in a kiln, you're heating the limestone to decompose it. Basically, you're taking inert rocks, heating them up, decomposing them so that they become reactive again. So that when you add water, they form a gel and then they set and harden into the durable concrete we all know and love. So what Sublime does differently is we break down the rocks, so we decompose them, but without using heat. So we use an electrochemical process that digests the rocks, breaks them down with reactive solutions that are regenerated electrochemically, and that produces the similar reactive powder. So the powder has the same chemistry, the same elements, but it doesn't have the same crystal structure because it's not been through a kiln. But that really doesn't matter because, people that pour cement, they're not worried about the chemistry of the product they use. What they're looking for is, that it reacts with the same amount of water, that it gels within the same amount of time, and that it hardens to form, an adequate compressive strength, and that it endures for a very long time. So I think this is important because, defining cement by its properties really lets you get to the root of the problem. If you're trying to solve the problem by trying to make today's cement, it leaves you with a limited set of options that, always come back to this 1400 degrees Celsius kiln. And so if you expand the parameters a little bit wider and you say, if we just want to make a high performance, low carbon cement, how do we go about that? And how do we go about that in a post-carbon world. So using your imagination, and you go ahead into a future where, it's expensive to pollute because you're held accountable for your pollution. And in that world, we know that there will be a lot of abundant renewable electricity. And because, renewable electricity is intermittent, there's also going to be a lot of really low cost electricity if you're able to take it in at odd hours and be flexible. And that's what an ambient temperature process allows you to do. It's not like heating a kiln where you have to have, a very constant stream of energy going into it. An ambient temperature process like this, you can ramp it up and down, and it goes faster and slower the harder you push it, but it is receptive to those fluctuating loads. So that's a bit about, how Sublime makes low carbon cement.
Why, Leah, is it easier to do what you are doing than just to capture the emissions of current cement production? If there's all the CO2 that's being produced by the breakdown of the limestone, wouldn't it be easier just to carbon capture and sequester than to create a new technology like what you're doing?
Neither of these things are easy. And I'd say, carbon capture is easy in a way. You're putting a hat on this cement plant, and, the carbon capture, I don't think it's actually as technically far along as people think. There have been, 2 industrial carbon capture plants. And if you look them up, these are from, 10 years ago. They haven't really performed well. And those are for coal-fired power plants. Carbon capture for cement at a industrial scale hasn't been demonstrated. And even if it worked like a charm, there's, it's also not the best way to decarbonize cement, because each ton of cement made in a kiln results in a ton of CO2. And, this is a 1 million ton per year plant. You're going to need a 1 million ton per year carbon capture plant adjacent to this cement plant. And so what that does is it doubles the capex of the cement plant. It doubles your opex. It doubles the cost of cement, at least. I mean, the doubling of cement with post-combustion carbon capture is, that's an estimate. It could be anywhere from 2 to 4 times more expensive, because every time you add onto a Portland cement kiln, you're adding on to the cost. And I'd say,
just to be clear, yeah, that's okay. Just for the uninitiated, a Portland cement is not cement made in Portland, Oregon, but rather it's the most common type of cement that we use, right?
Oh, thank you. Yes. So Portland cement is today's modern cement, the type that's made at 1400 degrees Celsius. And this is just to distinguish it from, Roman cement or other types of cement. It's really Portland cement that's the carbon intensive one that's dominant today.
Got it.
Thank you.
So you are just talking about the cost to carbon capture and sequester at current cement plants, and that raises the question of the cost of Sublime cement. Now, I know you all have a pilot plant. You're not yet commercially producing your own cement here, but what do you think, or what do you project are the costs of the Sublime cement that is made at room temperature rather than Portland cement, which is made in these extremely hot kilns? Like, are you going to be cost competitive with Portland cement, or is this going to be something for which there's a green tax, so to speak?
Yeah, ultimately, yes, we can compete on cost with Portland cement at scale, perhaps not at first. So first we have to achieve that scale, and going from 100 tons per year where we are today to 1 million tons a year, which is, the average small cement plant, it's going to be no mean feat to get to that scale. But we're constantly refining our projections with data from our pilot plant. And what we can say with confidence is that at scale, after we've, brought this to commercial scale and optimized it, we can, the limit of the cost of our technology is very similar to the cost of making today's cement. And that's because we're not adding on to a Portland cement plant like post-combustion carbon capture. It's because we're replacing that Portland cement plant. So, the CapEx is the same, and it's still a very expensive project. But what that investment gives you is more capacity for your cement. So imagine you have the choice between investing, $500 million into post-combustion carbon capture, which doubles the cost but doesn't increase your output, or you can invest $500 million into a Sublime Systems plant, which likely doesn't increase your costs. Maybe it increases your costs a bit, but it certainly doesn't double the cost of cement. And now you have more production capacity. And I think this is important because the US does import a tremendous amount of cement. And I think it's important to, domesticate our supply chains and, all these transportation costs, they cost carbon as well. We're shipping things from overseas.
Yeah, exactly. So where do you get this idea, Leah? Like, people have been for a long time heating up limestone to make cement. You think that an electrochemical process using renewable energy at room temperature is a better way to do it. But how did you even come up with this? Like, why were you thinking about ways to improve upon current cement practices, and why electrochemistry rather than just using heat?
Yeah, well, I can't take credit for the idea entirely myself. It really does take a village to develop these technologies. And in my case, that village was at MIT. So my background is in electrochemistry. I'm a battery scientist. I did my PhD funded by Tesla. We were developing chemistry for, developing their IP portfolio when they decided to build their mega factory. So I suppose electrochemistry is my tool. It's my hammer, and everything sort of looks like a nail. So after my PhD, I came to MIT to work with Yatming Cheng, who is a prolific inventor and serial entrepreneur in MIT's Department of Materials Science. Now, I didn't think we were, going to start a company, but I did choose to work with him because he is so creative and he solves problems. Like I think that's one of the most amazing things about chemistry is how creative you can be and how applied it is. And not every professor is like that. Some professors like to do more, analytical stuff or understanding first principles, but he really likes to apply stuff. And that's why I chose to work with him and bring my scholarship there. And together with another PhD student, Andres, we were trying to walk backwards from this tagline of electrochemical cement, because we were all battery scientists, the three of us. And, I think Yatming Chang, my co-founder, he has a very privileged place at MIT, being a professor there for so long and also having spun out so many companies. He can sort of see trends. And so we see this trend of, electrification and how the cost of renewable electricity is coming down year over year as, renewables and long duration storage come on board. And so really, I think our approach to making cement will be obvious in retrospect. But I think Yet was the first person to see this opportunity. But once you look at cement making, through this lens, once you put your mind into a post-carbon future where everything is, electric, and, there's a penalty for polluting, and all of these electrolyzers are, have come down the cost curve as they have in the past 100 years. Like the people who invented Portland cement 200 years ago, they didn't have access to electrolyzers and they didn't have access to renewable energy. I'd say Sublime Systems is like the electric vehicle of cement making, where it wouldn't make sense to power Sublime using a coal-fired power plant. And therefore, this idea was not obvious until the tides of change started to turn, and until the grid started to clean up. Now you can really think of how to electrify everything.
So you're talking about hundreds of years ago, before Portland cement, but my wife and I were in Italy like a year or so ago, and I was looking at these Roman structures from a couple thousand years ago, and obviously they had some pretty durable materials. Many of their bridges are still standing today. I mean, talking about over-engineering, they've outlasted their civilization. And, it makes me wonder, like, what were they doing? Like, they weren't emitting tons of carbon, I presume, to make all these structures. So what was the process used for making these type of durable materials in the deep past?
Well, it's funny that you bring that up, because Sublime cement is actually more similar to Roman cement than it is to today's Portland cement. And so the big difference between Roman cement and Portland cement is that Romans they still decomposed limestone in a kiln. So they still got up to 900 degrees. And so it was carbon intensive. And then they took that lime, that calcium oxide, and by the way, lime is where Sublime Systems is where we get our name. So they took that lime and then they mixed it with volcanic ash, which is a silicate. And those two react at ambient temperature to form what's called calcium silicate hydrate. That is the hardened form of cement. And it's a very, very durable phase that has very high compressive strength, and that it's, evidently withstood the test of time. So actually, that is how Sublime makes our cement without ever going into a kiln. We make carbon neutral lime through our process of digesting calcium bearing rocks. And often those calcium bearing rocks contain silica as well. And after we've digested the calcium out of those rocks, those silica rocks are now reactive, just like that volcanic ash that the Romans used. And so we blend calcium and silica together at ambient temperature with water, and it forms a gel, sets and hardens in the exact same way you would expect Portland cement.
I presume the Romans didn't even have a patent system, but I guess those patents would be expired a couple thousand years later. They were using them
that's right. And so the only thing that Portland cement does differently is go from 900 to 1400 degrees Celsius to get this particular crystal structure, which does actually harden faster than old Roman cement. And actually, if you made Roman cement today in the way the Romans did, it would be just as carbon intensive as Portland cement. So it doesn't really have an advantage unless you have an electrochemical process for making reactive calcium and reactive silicates.
Interesting. So let's talk about what you've actually done, because we've talked about what your technology is, basically taking limestone at room temperature and converting it into cement, which sounds pretty awesome and theoretically cool, but it's not just theory in the lab. You actually are making small amounts of this in a pilot plant. So how big is this pilot plant? How much did it cost to build? And what is it actually demonstrating?
Yeah, so we have been super focused on scale ever since we spun out of MIT in March 2020. So right as the pandemic was happening, we spun out, and we've just been laser focused on scale because, like I said before, this is the biggest industry by mass in the world. It's also a very stoic industry. They don't react to PowerPoints. They don't care what you can make in a test tube. They really want to see it in bulk. And that's, seeing is believing for these folks. So we were laser focused on scale. We were, of course, making cement at test tube scale. And so our goal and what we actioned on was just having a swift and massive carbon impact and measuring our carbon impact and our success in the volume of cement we produce and sell. So within the first year, we went from a gram to a kilogram. Then we went from a kilogram to 10 kilograms continuously. And, just after Christmas this year, we finished our 100-ton per year pilot plant and have really been turning the crank on that ever since. So optimizing it, using that material in internal testing, and then sending that out, getting those results validated in external labs. And now, we're at the point where we've got material in the hands of customers, and we can expect to do our first construction project by the end of the year and use that success to further build momentum and scale up once again to, what we're calling our kiloton plant, which is tens of thousands of tons per year. And from there, once that's validated at industrial scale as a first commercial plant, to scale up to 1 million tons per year, which is the point at which we could compete on cost.
Mm-hmm. So let me just ask you about that, Leah. So you're saying, we're recording this in September of 2023. You're saying that you're going to have your first commercial product by the end of this year, so within the next 3 months. Can you produce enough material from your pilot plant to do any meaningful commercialization?
Yeah, so 100 tons a year, that's about 50 trucks worth of cement if we were running it around the crank. So this is very much a boutique, handmade way of making cement. And I am very proud of our 100-ton per year pilot plant, and going from to achieving this in just 3 years from really test tube scale, I think is a remarkable feat from Sublime's engineering team and our R&D team. But you're right. I mean, we joke amongst ourselves that our pilot plant is, a cement plant for ants, using the Zoolander reference. It has to be at least 3 times bigger than this. So it's small. So what we're doing is we're getting customer traction. We're getting a nod from the industry like, yes, this cement performs exactly how we would expect it to be. We're building things with marquee customers. We're doing what we're calling champion pours with companies that really want to decarbonize their supply chain and see the value in low carbon cement. And I just want to speak about that for a second. So, there's a lot of pressure not only to reduce scope 1 emissions, but also scope 2 and 3 emissions. I don't know if your listeners are familiar with that, but scope 1 is what you emit yourselves. So actually cement plants have the biggest scope 1 emissions of any company in the entire world. The biggest polluters in the world are not Exxon or Aramco. It's Holcim and Heidelberg and all of these cement companies because they're actually releasing CO2 within their own footprints. But now the wealthiest companies in the States are software companies like Amazon, Google, Microsoft, Shopify, etc. And they don't have big scope 1 emissions, but they do have big scope 2 and 3 emissions, especially from their buildings and their data centers. So when you buy a ton of low carbon cement, even if it costs double, let's just be aggressive and say, it costs double or 3 times more than what ordinary Portland cement costs today. That doesn't end. Cement is so cheap. It's like $130 a ton. So even if you double the cost, what you're really getting is not only a ton of cement, which you'd have to pay $130 for, you're also getting a ton of carbon avoidance. This isn't a ton of carbon capture. This isn't, I think there's a lot of debate and controversy around direct air carbon capture and, what impact that has on actually bending the curve and the measurement and verification and reporting of all of that. I think there's no more durable and permanent way of, reducing climate emissions than avoiding the release of CO2 in the first place and not having to pick up after yourself. It's also worth noting that because cement is so cheap, it's actually a very, very small part of the overall cost of a building because, it's only 10% of the concrete and 80% of the cost of concrete is actually labor. So even if we were to double or triple the cost of cement, it ends up being one of the most cost-effective ways for a company to reduce their scope 3 emissions.
That's pretty interesting to note just what a small portion of the total cost of concrete the cement is, let alone the method of creation with all that labor. So that is particularly interesting. How much did it cost to build your pilot plant?
I'd probably say it's cost about $10 million to build the pilot plant and get it up and running. So we have raised just about $50 million. So 40 and change from venture capitalists, and then, government grants as well that have supported different aspects of our R&D.
What will it cost to build the kiloton plant? If it was 10 million to build the pilot plant, how much more do you need? So if you've raised 50 million, how much more are you going to need to raise either through equity or debt in order to get to that next level?
Yeah, so a lot. And, I'm not going to say it now because we are still settling on the exact size of our kiloton plant, whether that is, 10,000 tons per year or 30,000 tons per year. It really changes the cost a lot because if your readers or listeners can imagine a graph of, cost of producing cement versus scale, it's a very steep exponential drop off in those early scaling factors. And then it starts flattening off around, 500,000 tons a year. So we really need to get to the flat part where, you're making it as big as possible to get those economies of scale. But at a small scale, you get, exponential cost benefits by making it larger. Now, the thing is, for a demonstration scale plant, your goal isn't to make a profit at this next scale up. Your goal is to validate the technology, validate the product very quickly so that you can de-risk the project finance and get bankers and EPCs comfortable that you won't build a lemon once you scale up to 1 million tons a year. So that leap from 100 tons a year, which where we're at today, and 1 million tons per year is obviously enormous. So actually, this is what's called the valley of death in industrial decarbonization, because if you have a startup that, plans to decarbonize something so large as cement or steel, let's say, these are not modular technologies per se. So you can't de-risk it at a small scale and then scale it up. You really need to put quite a lot of money into an industrially relevant minimum viable commercial plant. And that scale is not designed to compete on cost. If you were to take today's Portland cement plants and scale them down to 10 and 30,000 tons per year, the cost would also balloon. So I can't answer that question exactly because I don't have these numbers right now, except to tell you that they are quite large.
Got it. Okay. Obviously, you raised this money at a time when venture capital was more free-flowing than it is today. You're going to have to go out and raise a lot more money, not sure how much, but a lot more money. So do you see a pathway to doing that in the current climate where venture capital markets have dried substantially compared to a year or two or three ago? Or do you think there will be some other like project financing or debt or something that you'll do that won't be equity financing to accomplish these goals of scale up?
That's a very good question. And, I don't want to, predict the future, but I think what Sublime has done in the past 3 years is remarkable. I think our team is I think our team is second to none. If I am to brag about anything, I will brag about our team. Mike and Jesse and all those folks have really done amazing things in making this real and putting material in the hands of customers. I also believe in our technology. Like I said, I think this will be obvious in retrospect. I think Sublime is positioned to be, a 100-year-old company. I think in this post-carbon world, our technology will still be relevant. And I think there's so many avenues of improvement. We are going out there with, the fastest version of Sublime Cement, but there's so much more we could do to refine our process and refine our technology. So I think that venture capitalists, I know the market is cold, but I think if you have, an amazing team, if you have demonstrated traction, if you have momentum with customers, if you have that, I think there will be money out there for us. So I'm not particularly worried. We're still seeing a lot of investor interest from deep-pocketed people who, to the theme of your podcast, not only want to make money, but also want to do something good, want to make the world a better place. And frankly, I think most people also want to have a legacy. I think they want to tell their kids that they were part of doing something that was monumental and ambitious and courageous and something also that took a lot of work and perhaps had a lot of risk, but that you made it through. So I know there's a lot of hell and high water in Sublime's future, but I think, my team is here for that. I don't hire cowards and, our investors aren't cowards either. I know a lot of investors are emotional and, get cold feet. Like, nope, not our investors. So those are the type of folks that I'm looking to bring on for the next round.
I'm envisioning the Sublime job descriptions that you post, and it will, say all the characteristics that you're looking for. Works well on teams, works well under pressure, isn't a coward. That's the main criterion to select for. That's very cool. So obviously you're doing this because you want to do some amount of good in the world and try to solve part of the climate crisis, which of course is very admirable. And this whole reason, as you note, that you're on the show right now. If there's other people, Leah, who are thinking about trying to do something important in the world, and they might want to take your journey as an inspiration to them and say, hey, look, this person was really interested in science and found a way to start a company, has raised $50 million for it so far and is keep on going and hopefully will raise a lot more. The question is, like, what else might they do? Is there something that you hope that somebody listening, Leah, to you right now might take up the mantle and start their own company to do some amount of good to solve some social problem?
Yeah, I would love to help that type of person. And I know that type of person is likely to be listening to your podcast. So, I screw up all the time. I'm not risk adverse. I take risks and I often fail, but I have to say there's a couple things that I have done right that have paid off in a really big way. And that is, I work really hard. I care a lot about what I do. I think about it in my sleep. I'm really driven. Work is fun for me. It's my adventure. You can go on vacation to all these crazy places, you can have adventures, you can meet the locals, you can have some cool stories, but that's actually not special. All you need to have is like money and some spare time. But having a really kick-ass career, like that is something only you can do, especially if you're in a creative capacity. Like only you can create the things that you create. So I would just encourage folks like, work hard and don't be scared of working hard. I know some people get really burnt out and there's this culture of work-life balance. And I honestly appreciate that, because if someone didn't encourage me to take a break, I would never take a break and I would probably hurt myself. But I also don't want people to take that to heart too much, because I think you really do have to be driven, and those flames get stoked. The more you feed them, the brighter they grow. So just work really hard and actually like really want to have it. And the more you want to have it, and the more it hurts you. Like, I don't think this will come without pain. Like there's no pain, no gain. So I would just encourage working hard. And then the other thing I would encourage is, work with really smart people. Like gravitate to the people who are accomplished, who share your vision, who want to get things done. And I'm just thinking from my story, like working with Yet Ming Cheng, who is, a really good person and a charismatic person and a brilliant person who wants to solve problems and has the same energy as me. And we can bounce ideas back and forwards and encourage each other and correct each other. Go find people like that, and they, learn from them. And they could be anywhere. They could be at a university. They could, I don't know, just go find birds of a feather and work hard together.
I like that. Yeah. Instead of flocking, birds of feather, work hard together. It makes me think of your commentary. Makes me think of two different things that people have said to me before on the show. One was a CEO whose company had been acquired for a lot, and he said, the idea of work-life balance sounds nice, but why would I recommend something that's the polar opposite of what I did to be successful, which was no work-life balance? And then another person on the show made a funny remark and said, I really hope that our competitors have awesome work-life balance. That's what I hope. Which, is fair enough commentary, of course. Finally, go on. I'm sorry.
It's funny. I'm not a hard ass. And honestly, within Sublime, I do promote work-life balance, because I think 9 to 5, you can be just polka dotted with Zoom meetings and you can be just pursued by all these things. But like, you need some quiet time away from your colleagues to get the real work done. And so and I think your best ideas don't come to you when you're replying to emails. So I actually am a huge advocate of work-life balance, and you can do whatever you want outside of 9 to 5, Monday through Friday. You can choose to work if you want, and I often do, but do what makes you happy, because I think you also have to be happy and strong to go on a journey like this. So I'm definitely not a hard ass, but I would agree with, your previous guest that you need some tiger blood to make this happen. And it gets easier the harder you push. So in my experience anyway.
Very nice. Your two big lessons here: tiger blood needed, no cowards need apply. Okay. So finally, Leah, let me ask you, there's obviously a lot of thought that you have put into your company and to entrepreneurship in general. Have there been any resources for you, whether books or otherwise, that were helpful for you that you recommend for others who want to try to also leave some positive imprint on the world?
Yeah, everyone's always recommending books, and I have like this bookshelf of, books that have been recommended, and I don't know, some of them are kind of obvious, you could basically sum that book up in like a sentence or two. I think what's helped me most is communities of founders, like talking to people who are doing the same thing, like going back to those birds of a feather. So I was very lucky to get what's called an Activate Fellowship. So after my PhD, when I had this idea and wanted to see if it could grow, I got a 2-year fellowship with this program that has, scientists that want to commercialize their inventions. And so that's a group of people. And I think having your group of people that, are either a couple steps ahead of you and can give you advice and help you see your own corners, or a couple steps behind you, and, you can pass on those learnings and help help your community too. So I think the biggest resource for me is, my friends who are also founding awesome companies and just having those lifelines. Because I think no one really understands just the chaos of building a startup and all of the, uncountable challenges like grains of sand on a beach. So just being with people who really get it and can sometimes talk to you about it is just, the biggest resource, worth more than, however many dozens of hours you would need to plow through a couple books. It's the people, it's your helpers.
Cool. Yeah. Well, one of the themes of the show is definitely that it is, successful entrepreneurship looks very attractive. The reality is that it's extremely difficult. And as I've said before, there's a line from Ben Horowitz, which I take to heart. He's the co-founder of Andreessen Horowitz. And he says that when you found your own company, you will definitely sleep like a baby because you will wake up every 2 hours and cry. And it's it's a good lesson and reminder that, it's life can be tough, but it's worth fighting for. It's worth trying to solve this crisis that we're in this particular case, the climate crisis. And I'm grateful, Leah, for everything that you're doing to try to help create a cleaner, greener construction industry. And I hope that one day I will be encased in Sublime cement. What a great way to spend a day. I hope I get to do that.
Well, when you say it that way, you remind me of like the mafia, like encasing someone, giving them like a cement boot or something. So I hope not that way, but I hope encased in a lovely Sublime cement skyscraper, perhaps.
Very nice. Well, if the mafia is ever going to throw me into the river with cement boots on, I will have to make sure that it's Sublime cement.
Okay, thank you.
Thanks for listening. I hope you found it useful, and if you did, please let the world know. Leave the show a 5-star rating on your favorite podcast app and share the episode with your friends. Who knows? Maybe you'll inspire one of them to be in the business of doing good themselves.